Hey there. Have you ever wondered if human beings are, predictable enough to be studied exactly like gravity? Well, in today's explainer, we're diving deep into the scientific nature of demography. We're going to start right at the ground floor with the basic mechanics of how populations shift, and we'll end on a pretty profound philosophical question. What actually makes something a scientific law? It's a fascinating journey, going from simple head counts all the way to universal truths about human behavior. So here is our roadmap for today. We'll be looking at the two aspects of demography, understanding demographic variables, exploring the types of population studies, asking if demography is really a science, comparing natural and social sciences, and finally, tracking the journey from hypothesis to law. Let's get right into it. Starting with Section 1, the two aspects of demography. To kick things off, we need to look at how experts Hauser and Duncan break down this massive field into two very distinct branches. First up is formal demography. The crucial thing to remember here is that formal demography is strictly numbers defining numbers. It's like using the number of women of childbearing age to define the overall birth rate. It's a totally closed mathematical environment. But on the flip side, we have population studies. This brings in the messy, real-world context. It asks why those birth rates are changing by looking at non-demographic factors, like are economic recessions causing people to delay having kids? Is a shift in cultural attitudes altering the numbers? Or are housing market spikes pushing young families out of cities? Population studies essentially widen the lens to capture the full human experience that's sitting right behind the raw data. Moving on to Section 2, Understanding Demographic Variables. Now, before we can really dig into those studies, we have to grasp the foundational building blocks, which are variables. Simply put, a variable is just something that changes or varies from person to person or time to time. Think income level, education, or age. But there's a golden rule here. You absolutely cannot define a variable using its exact antonym. You can't just say, well, a dependent variable is the opposite of an independent variable. That doesn't tell us anything about how it functions. Instead, I love how the source material puts this. Think of the independent variable as the influencer. It's the spark. It's the cause doing the changing. The dependent variable is the effect, or who gets influenced. It reacts to the influencer. Keeping that influencer and influence dynamic in mind makes reading complex data so much more intuitive. Whenever you look at a new study, just ask yourself, what's the spark and what's the reaction?
All right, Section 3, Types of Population Studies.
So what's really interesting here is seeing exactly how these influencer variables interact to create different frameworks. First is formal demography again. Like we said, this is a closed loop. A demographic variable, say the age composition of a city, acts as the independent variable. This directly influences another demographic variable, like the overall birth rate. It's a pure, self-contained mathematical system. And this is a huge deal for statisticians because it makes the data highly predictable. When you don't have to worry about all those messy outside factors, you can create incredibly precise models of what a population might look like decades into the future. But then we crack the loop wide open with a population study type 1. Here, non-demographic influencers become the independent variables. Think about how a person's social class or even specific health habits like cigarette smoking impact demographic outcomes like the death rate. This type of study focuses heavily on the qualitative, socioeconomic context of our lives. It's where the hard numbers literally meet the reality of daily life, showing us exactly how our choices and our environments shape our communities.
Conversely, a Type 2 population study flips the script entirely. Now, demographic shifts are the influencers. How does a rapidly aging population or a spike in the birth rate drive changes in completely non-demographic areas like voting behavior or economic growth? Because you're using demographic inputs to predict massive societal outputs, this requires some seriously heavy mathematical tools, things like life tables and complex survey projections. It is wild to see how raw numbers can literally restructure the politics and economy of an entire nation. Which brings us to a massive pivot point in Section 4. Is demography a science? It's a genuinely provocative question, right? If human populations are inherently so unpredictable, constantly influenced by shifting economies, cultural trends, and personal choices as we just saw, how can studying them be rigorously scientific? Are we dealing with a hard science here, or is it something else entirely? To figure that out, we have to look at the three core purposes of science. Step 1 is description and observation, just simply noticing what's happening. Step 2 is the discovery of regularity, finding a pattern that repeats itself over and over. And Step 3 is the formulation of theories and laws, actually creating universal rules that govern that regularity. If a discipline can move through these 3 steps, it absolutely earns the title of a science.
This classic example brilliantly illustrates that progression. Step 1, observation, you see an apple fall. Step 2, regularity, you discover that all fruits fall from trees. And step 3, formulation, you create the theory of gravity, a universal rule that is true regardless of place and time. An apple falls the exact same way in Tokyo today as it did in London 300 years ago. It's absolute.
But that leads us straight into Section 5, Natural versus Social Sciences. Because here is where we hit a snag. Dropping an apple is very, very different from studying human voting behaviors. Natural science is considered error-free. The result is always the same and doesn't depend on human socio-perspectives. Social sciences, like demography, are fundamentally different. Human behavior just doesn't follow perfect regularity. Different cultural perspectives lead to different outcomes, which means the data constantly shows variations. You're never going to find a universal law of marriage, exactly like you find a law of gravity. People are simply too complex for that.
However, despite all those variations, demography absolutely is still a science. Why? Because the word science means all knowledge collected through systemic methodology. It's about how you do the work. It's the exact difference between astronomy and astrology. Astronomy is a science because it uses rigorous systemic methodology. Astrology is non-scientific because it relies purely on speculation. Demography might deal with unpredictable people, but it uses rigorous mathematical and statistical methods to find the truth. It is a true multidisciplinary science.
Finally, let's look at Section 6, From Hypothesis to Law. Following that scientific method, we build the hierarchy of human knowledge. We start with a hypothesis, an evidence-based educated guess. We verify it, and it becomes a theory. A theory explains how nature develops, but crucially, it might still have exceptions because we don't know everything yet. Finally, if a theory is rigorously tested over time and proven to be a universal rule with absolutely zero exceptions, it graduates to a law. That is the ultimate peak of knowledge.
But wait, remember what we just learned? Human populations almost never follow rules with zero exceptions. Variations are basically built into our nature. There's no demographic law of gravity. So I want to leave you with this ultimate question from our source material to ponder. If social science inherently shows variation, who or what will ultimately decide if a demographic theory can ever truly become a universal scientific law? It's a fascinating puzzle, and experts are still trying to solve it today. Thanks for joining me on this one.